In today's episode, you will learn how to do two-way communication between Arduino and Blynk through Nodemcu ESP8266 Wi-Fi module. At the end of this tutorial, you will be able to monitor multiple analog sensors and you will also be able to control multiple loads. In this project, no multiplexers will be used. All the sensors and loads will be connected in a normal way. Let's get started. The components that we will be needing for this project are number 1, Nodemcu ESP8266 Wi-Fi module, number 2, 5x7 cm Vero board, number 3, 470 microfarad capacitors, we will need 2 of these, number 4, female DC socket, number 5, 7805 voltage regulator. First leg is the input, middle one is the ground, and the third one is the output. Number 6, LED. The longer leg is the anode and the shorter one is the cathode. Number 7, 330 ohm resistor. Number 8, female headers. Number 9, variable resistor. I have already connected some jumper wires so that it can be easily connected with the Nodemcu. Number 10, LDR, which stands for light dependent resistor, and number 11, 220 volt indicator lamps. These components can be purchased from Amazon. The components purchase links are given in the description. This project is based on my previous 2 tutorials. In this tutorial, you will learn how to install the Nodemcu ESP8266 Wi-Fi board, and how to download and use the Blynk library, and how to fix the USB UART driver error. While in this tutorial, you will learn how to make a power supply for Nodemcu ESP8266 Wi-Fi module so that it can be easily powered up using a 12 volt adapter or battery. The tutorial links are given in the description. So this is the final circuit that we will be using today. Let's have a look at the complete circuit diagram. This is the complete circuit diagram. This schematic is designed in GateSoft Eagle 9.1.0 version. If you want to learn how to make schematics and PCBs, then watch my tutorial. The links are given in the description. The power supply is already explained in my previous tutorial. You can use this power supply to power the Arduino by connecting its output with the VN pin of the Arduino. But I will connect a 12 volt adapter directly with Arduino, and I will power up Nodemcu using the Arduino's 5 volt and ground. As you can see, the Arduino's 5 volt is connected with VN pin of the Nodemcu and the ground is connected with ground. All the grounds are connected. A variable resistor is connected with a 0 pin of Arduino, and LDR is connected in series with a 10K resistor, which makes a voltage divider and is connected with A1 pin of the Arduino. The TX and RX pins of the Nodemcu are connected with pin 2 and pin 3 of the Arduino. So the Nodemcu will communicate serially with Arduino Uno through pin 2 and pin 3. Pin 2 is RX and pin 3 is TX, which will be defined in the programming using the software serial library. For controlling these relays, we will need relay drivers. The relay drivers simply consist of the 2N2222 NPN transistors, 10K resistors and diodes. Watch my tutorials on relay driver circuit design calculations. The link is given in the description. This tutorial covers everything you need to know about relays. As you can see, a 10K resistor is connected with a base of 2N2222 NPN transistor, as it's a BJT bipolar junction transistor, a current control device. That's why we need a current limiting resistor. We usually use a 10 kilo ohm resistor. The emitter of the 2N2222 NPN transistor is connected with the ground, while the collector is connected with one side of the relay coil, while the other side of the relay coil is connected with 12 volt. This relay can be energized and de-energized using this transistor. As you can see, this relay consists of 5 pins, 2 coil pins, common, normally closed and normally open. These 3 pins have no physical connection with the coil pins. In my previous tutorial based on home automation using Nodemcu and Blynk application, I have explained this in very detail. And in that tutorial, I also explained how to connect a lamp or any other load with the relay's output. The link is given in the description. All the connections are exactly the same. These are freewheeling diodes used against back EMF protection. So this is the relay module. You can also use a ready-made relay module. These are 10 kilo ohm resistors connected with a base of 2N2222 NPN transistor. These are the 1N4007 diodes connected across the relay coil pins. These are 12 volt SPDT type relays, and these are the terminal blocks. I have soldered some jumper wires so that this relay module can be easily interfaced with other circuits. This relay module consists of 7 relays, but I'll be using 2 relays. Connect these 2 relays with pin number 13 and pin number 12 of the Arduino Uno or Mega, and connect the relay module ground with the ground of Arduino. So that's it. Now let's make the Blynk application. I will use a screen recorder on my cell phone so that you can easily understand. First of all, open the Blynk application. Set the project name as Control and Monitor. Click on the Choose Device and select a Nodemcu. Make sure you set the connection type to Wi-Fi. Then click on the Create button. An authentication token will be sent on your email ID, which will be then used in programming. Simply copy and paste it in programming. Click on the screen and add gauge. Click on the gauge and set the name as variable resistor. Now click on the pin and select virtual and select V2. Change the font. Click on push and select 1 second. Now add another gauge and repeat the same steps. Click on the screen and add numeric input. Click on the numeric input. Click pin and select the virtual pin 10. Set the minimum value to 10 and the maximum value to 11. These 10 and 11 values will be used to control the relay connected with pin 13 of the Arduino. And finally set the name as relay 1. If you want, you can also change the font. Now repeat the same steps for the other numeric input and rearrange the gauges and numeric inputs and change the color. Our basic application setup is completed. First, let's discuss the Arduino programming. Hash include software serial.h. This is the library that will be used for making a serial port on pin number 2 and pin number 3 of Arduino. Using software serial library, we can define multiple serial ports. Software serial Nodemcu 2, 3, 2 is the RX and 3 is the TX. Long integer data. Integer relay 1 equals 13. Device number 1 is connected with pin 13 of the Arduino. Integer relay 2 is equal to 12. Device 2 is connected with pin 12 of the Arduino. Integer sensor 1 is equal to A0. Variable resistor is connected. Integer sensor 2 is equal to A1. LDR is connected. Integer sensor 3 is equal to A2. Over here you can connect any other sensor, but I'll be using only two sensors, the variable resistor and an LDR. These are the three variables of the type integer which will be used for storing the sensor's data. Integer is data 1 is equal to 0. Sensor number 1 data, which is a variable resistor. Integer S data 2 is equal to 0. Sensor 2 data, which is an LDR. Integer S data 3 is equal to 0. Sensor 3 data, which can be any other sensor. String C data. C data is a variable of the type string, which will be used to store the complete message consisting of the sensor values. As you know, my friends, every Arduino and Mcu program has at least two functions, which are the void setup and while loop function. Void means that this function is not returning any value, while the empty parentheses means that this function is not taking any arguments as the input. Serial.begin 9600 activates the serial communication at baud rate of 9600. This will be used for the debugging purposes. Nodemcu.begin 9600 activates the serial communication with Nodemcu connected with pin 2 and pin 3 of the Arduino, and 9600 is the baud rate. Pinmode is a function and it takes two arguments as the input, the pin number or pin name, and the status, which can be input or output. Set relays as output and set sensors as input. Then starts a while loop function. If Nodemcu.available is equal to 0. If we have not received any data from Nodemcu, then what to do? We simply read the sensors using analog read functions and store the data in a variable is data 1, is data 2, and is data 3. Then we add all the sensor values and store it in a variable C data. C data is equal to C data plus is data 1 plus, then there is a comma, plus is data 2 plus comma plus is data 3. Comma will be used as a delimiter. Serial.println C data. This instruction is used for debugging purposes to see the result on serial monitor. Nodemcu.println C data. This instruction is used to send the sensor values to Nodemcu. Delay 1000. Delay of 1 second is 1000 milliseconds equal to 1 second. C data is equal to empty double quotes. This instruction simply empty the C data variable. If Nodemcu.available greater than 0, this instruction means if we have received data from Nodemcu, then what to do? Data is equal to Nodemcu.parse integer, store the value and a variable data. Delay of 100 milliseconds, serial.println data. We use this instruction for debugging purposes to check if we are receiving the data. Then we use if conditions to compare the received value and then turn on and turn off the desired relay. If 10, then relay 1 low. If 11, then relay 1 high, and so on. Now let's discuss the Nodemcu programming. Before you start the Nodemcu programming, first of all make sure that you download all the necessary libraries and you install the Nodemcu board, and you also install a driver for the USB UART. I have a separate video on this. The link is given in the description. Define Blynk underscore print serial. These are the four variables of the type integer which will be used to store the values sent from a Blynk application. I will be using pin value 1 and pin value 2. This is the authentication number which was sent via email. I simply copied and pasted over here. This is the name of your Wi-Fi and this is the password. Simple timer, timer. String my string. MyString is a variable of this type string, and this will be used to store the complete message received from the Arduino, which consists of the sensor's data. Character or data, this will be used to store the received characters. Integer first value, second value, third value. Sensor values will be stored in these variables. This function sends Arduino's uptime every second to virtual pin 1. In the app widget's reading frequency should be set to push. This means that you define how often to send data to Blynk application. Void my timer event. You can send any value at any time. Please don't send more than 10 values per second. Blynk.virtualWrite v1, millis divided by 1000. Unlike Arduino Uno and Mega, Nodemcu has also at least two functions, which are the void setup and void loop. Void means that this function is not returning any value, and the empty parentheses means that these functions are not taking any arguments as the input. Serial.begin 9600 activates the serial communication at baud rate of 9600. Blynk.begin authorization SSID and password. Setup functions to be called every second. Timer.set interval 1000 sensor value 1. Timer.set interval 1000 sensor value 2. Sensor value 1 and sensor value 2 are user-defined functions which are called every 1 second. We can change this time. The number of these functions depends on the number of sensors we are using. Then starts a while loop function. If serial.available equals 0, this means if we have not received any data from the Arduino, then simply executes these functions, blynk.run and timer.run. If serial.available greater than 0, our data is equal to serial.read, read the serial port and store the characters and our data. MyString is equal to MyString plus our data. This instruction means add the received character with MyString and store it in MyString. The purpose of this instruction is to make sure that we have received the entire message. Then we simply divide the entire message into three strings L, M and N. We are using comma as a separator. Then these three instructions are used to convert these strings to integers and store the values in a variable first value, second value and third value. MyString is equal to empty quotes. This instruction is used to empty the string. These are user-defined functions, and we simply use these functions to send values to Blynk application. As you can see, the first value is stored in sData, and then the sData is sent through Blynk.virtualWrite function to the virtual pin v2, and similarly for the other function. This is a user-defined function of the type string, and it takes three arguments as the input: the data, separator and index. This function is used to split the string. In Blynk, app writes values to the virtual pin 10. Blynk_write a v10. This instruction assigns the incoming value from the pin v10 to a variable. Serial.print pin value 1. This instruction is used to send that value to Arduino Uno Omega, and similarly for v11. Now we are done with the programming. I have already uploaded these programs. Now let's watch this project in action. I'm using the breadboard only for the 5-volt and ground connections. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.